Moving to our next speaker, Hunter Williams, Honeybee Robotics Space Resource Exploration and Excavation Capabilities. Hunter, are you there?
Yes, hi. I'm going to share screens now.
Great, lovely to see you. The floor is yours.
Okay, wonderful. You can all see my slides, correct?
Yes.
Great. So yeah, I'm Hunter Williams. I'm from Honeybee Robotics. I'm a business development engineer. I do a lot of proposal writing and concept development. So I'm just going to talk a little bit today about what we are doing at Honeybee and what we've done in the past. So Honeybee is fully vertically integrated, and we do everything on a spacecraft that you can think of. We do robotic mechanisms, we do our own avionics, we do actuators, flight software, we do full environmental testing, and we also do the beginning stages as well. Trade studies, concepts, and development, and we do work internationally. So when I say we do everything from end to end, I mean we go from technology readiness level as defined by NASA 1 all the way through 9. We've been on quite a few NASA missions, and it's important to note that the TRL, the first 4 levels, a lot of times are things that people can figure out themselves sometimes. You know, you have a good idea, you take it, you run with it. These middle TRLs, the 5 and 6, where you have to do environmental testing and vacuum and under temperature, sometimes can be a little bit difficult. And getting things ready for flight can be some of the hardest things for smaller companies to do. So what Honeybee excels at is helping other companies to get there. We get people out of the quote-unquote TRL valley of death, which is the middle TRLs. So these are our facilities in California. We bought an old Walmart and turned it into a science laboratory. So we do all of our own building on site and all of our own testing as well. The bottom right picture is our geotechnical lab, where we have a simulant library, and we have multiple 3-meter tall chambers, as well as environmental chambers that mimic other planetary surfaces such as Mars and Titan. Some upcoming missions that we're on: the Dragonfly mission that will be going to Titan, as I mentioned before. We are doing most of the sampling on that. The MMX mission, the Martian Moons Exploration mission with JAXA, which we will be going to Phobos and taking the first sample back to Earth from the Mars system, is going to be in a few years. And upcoming, we have several CLIPS commercial payload missions, including PlanetVac, LISTER, and we will be doing some very fun stuff with Prime 1 and Viper, which I'll get to in a second, where we will be taking some of the first samples of lunar ice. So we do a lot of testing in different places on Earth. We go to the Atacama Desert quite regularly. We go to Greenland, we go to Antarctica, because a lot of our systems are built specifically for extreme environments. So Honeybee doesn't just build systems that can go and survive for a week or so. We build things that can potentially survive for years. It's very important to us because Honeybee wants to be the company for ISRU technology development. So we focus on the long term. Everything that we build can survive for multiple years. We have some important firsts that we're very proud of. We were the first to sample Martian ice with our Honeybee, with our ISAD system. And then we were the first to touch the inside of a Martian rock with the rock abrasion tool. It's shown at the bottom there. We were on the Curiosity rover, and we were on Mars 2020 that landed recently. So on the Curiosity rover, we built the sample carousel, and on the Mars 2020 rover, we have a dust mitigation tool for wiping off the surface of sample tubes, as well as the witness plate assembly. So the witness plate assembly is probably the cleanest piece of space hardware ever built, and it's going to work with the sample caching system to make sure that all of the things that are taken from Mars are actually from Mars and not from Earth accidentally. The dust mitigation tool we're particularly proud of because we brought it from TRL 1 to 9 in under 7 months. So if you're familiar with the technology development timeline, you know how unbelievably fast that is. So these are the drills that we're going to be putting up on the moon very shortly. On the left especially is the one that we're immediately putting on the moon with the Prime and Viper missions. So this is the TRIDENT drill. It takes small bites of the surface and then it transports the cuttings to a place where instruments can take a look at them. So hopefully we're going to be landing in a spot with Prime or with Viper that has icy rich soil just underneath the surface. And we will be taking measurements of that ice for the first time. To the right is the PVEX system, and this is a full ISRU system and sampling system. So this can be used either for water extraction of lunar icy regolith, or it can be used for exploration, as in figuring out where the ice is. So it's a full end-to-end system. And we've shown in the laboratory thus far that we can extract ice and turn it into vapor water. And as I was saying before about our stuff being built to last for a long time, this is one of the places where it really shows, because we've built dust-tolerant mechanisms and put them all over these two drills. So we have dust-tolerant slip rings, we have dust-tolerant wire harnesses and cables for the actuation system, as well as vapor feed-throughs, vapor-tolerant joints, so that the vapor as it flows through the system doesn't cause any rusting or carry any dust away and cause some abrasion. So it's an end-to-end system that is capable of taking dust for years, and that's something that you won't find anywhere else. So, as I said, we were going to be on the Viper mission in 2023, going to the moon. We were going to be taking, and this is a picture of, I believe this is a picture of Resource Prospector and not Viper, but the form factor is very similar, so I just went ahead and left it up there because it's a pretty picture. But yeah, the TRIDENT drill is going to be kind of centrally located, and it's going to be delivering sample to MSOLO and NERVIS, to NASA payloads. So in the very near future on the CLIPS mission, we are going to be sending LISTER. So this is a coiled tube drill. Drilling is oftentimes thought of as only done with augers or with core drills, but we are finding at Honeybee that pneumatic drilling systems using air or gas to drill is very useful on the moon. You can use 1 kilogram of gas to move, 1 gram of gas to move 1 kilogram of regolith. So it's a highly useful system we're finding because it fits into a very small form factor while moving quite a bit of regolith out of the way. This is the cross-section of something called PlanetVac. So PlanetVac is also a pneumatic system, but this is a foot or something that goes near a foot, and it causes an eruption in the regolith and then carries it through the system to wherever it needs to go. So why this is particularly useful is that sample handling is actually quite difficult on the moon, but also anywhere in space, simply because in a microgravity environment or in a vacuum environment, dust will behave differently than it does on Earth. So it can coat the inside of tubes very easily, especially in microgravity. When electrostatic forces are dominant, it will kind of act like a gel, creep along the surface by itself. It behaves very interestingly, but what PlanetVac allows for is immediate delivery and size sorting anywhere you need it. So we're going to be trying this out in the CLIPS mission, but we are also going to be using that as part of MMX with an altered design. And Honeybee feels like this may be one of the sampling methods of the future. It may be a sustained presence on NASA missions from here on, simply because of how well it does sample handling. Here's a video and a few more images of PlanetVac. We tried it out on one of the Masten landers, and we're very excited because it works very well. So we can collect quite a bit of sample in a very short amount of time. So for long-term use, for ISRU purposes, PlanetVac is not necessarily what we're looking at, but it is going to be very good for short-term or short-duration sampling missions. We build a lot of robotic arms at Honeybee. So some things are easily recognizable as robotic arms, like in the top right. That's one of our surgery robotic arms that we built. Bottom left, also with end effectors can be seen as a robotic arm, but all of our drills really fundamentally are robotic arms because they are semi-automated and they have multiple axes of control. So as you can see in the top left image, that is the TRIDENT drill taking a sample out of a piece of concrete. So I just like watching it move, it's kind of fun. A lot of times people ask us, like, do you have a robotic arm that we can use just stock off the shelf? And what we oftentimes will tell people is we can do that, but it's better to develop it specifically for your system in mind, because as you can see, the robotic arms can look very different depending on how they're being used. And that is important because Honeybee likes to build things to spec. So what we do is we have these dust-tolerant actuators that can operate for years on the lunar surface if necessary, and we'll change the length of the arms, we'll change the material of the arms, whatever is necessary for your specific application. We also have dust-tolerant connectors. This is one of the things that I'm most excited about in the near future. We've developed a connector with a special material that is both abrasion resistant and cold vacuum resistant. It can be used with multiple mate-demate cycles. So for anyone who is building up facilities for future water processing plants on the moon or things like that, and you need to be able to connect or disconnect from a power source, this is going to be a potential. So of course there are companies like Astrobotic that are developing hands-free or remote power sources, remote charging sources. But what this allows for is tool changing, multiple different arrangements of power pins and data, and it also allows for scaling. So this can be done with very large or very small systems. So we can have pretty much an infinite variety of preloads, meaning we can go anywhere from the preload that a astronaut could give with a hand tool all the way up to the preload that would be necessary for full facilities level equipment, meaning like a multi-megawatt solar panel or the like. We have a motion control group in Longmont, so most of the things that I have just showed you are for our Altadena office. We do have a large Colorado office as well, and they focus on satellite technology. So this is a little bit outside of my wheelhouse, but I wanted to show you all that if you're interested in any of our high reliability actuators or electrical systems for satellites, then we have that as well. And we provide both the design and finished products from the Longmont office. And we similarly, we do our own avionics there as well. So we build our avionics for spacecraft payloads that are going to planetary surfaces at the Altadena office, but they build lots of avionic systems for satellites out of the Longmont office. And we've worked with a number of different satellite providers, such as OneWeb and Lockheed Martin. So we're very happy to work with any of you, talk to any of you. And I know this is a little bit different of a presentation than some of the other ones, but I wanted to focus on capabilities that specifically might be helpful to some of our friends in Luxembourg, because so far we haven't done too much business with you all, and we're excited to potentially try that in the future. So thank you so much.
Thank you so much, and I'm going to throw directly to Advanit, who is going to ask you a question.
Yes, Hunter, I see a number of questions on the chat, but perhaps you can address them offline. But I have a question. You mentioned for your dust mitigation device The impressive performance of TRL1 to 9 in 7 months, does it mean that you started working on it 7 months before the flight?
Yes, it was an emergency situation. Basically, they were doing some final testing, and they found that the tubes that they were using for sample, like NASA found that the tubes that they were using for the sample caching had the potential to be kind of locked up and not closed properly. So they called us and they said, "Can you do this?" And we said, "Yeah, we'll put engineers on it around the clock." And we did. We were working not quite 24 hours a day, but very close for about 7 months.
Very impressive. Thank you.
Thank you.
Thanks ever so much. And again, you'll see on the chat, there's quite a few questions to you there, which you can log on and reply to when you have time.